I got cut out on the end of that last video, so I had to make this last one to see our last example here. So this is another fractional distance where we're not looking at the midpoint. I will say if you have some kind of half, you could do a repetition of midpoints. Like you could find the midpoint of NM and then the midpoint of that segment, and that would also be a quarter of the distance. However, it's not always going to be a nice, easy version of some half. So this is going to work anytime you have fractional distance that aren't halves. It's the long method I mentioned where you have to find the whole distance, take that fractional distance, and then move towards one of those points. So what we're going to do, and the difference here is we're working in the XY plane instead of just on a number line, but you're just going to approach the problem the same exact way. You'll just have to do the same thing for the X's and the same thing for the Y's. So first I'm going to see how far apart the X's are. So I have 2 and minus 3. So that distance, bigger minus smaller, okay, so that's 5. Alright. And so that's how far the X's are from each other. Now let's see, we'll say it's for the X's. For the Y's, bigger is 3, smaller is minus 3. 3 minus 3 is a 6. Okay, so I'm supposed to go a quarter of the distance. So what I'm going to do is multiply both of these by 1/4. So a quarter times 5 is 5/4. If you really like decimals, you could say or 1 point, so that's 1 and 1/4, 1.25. For this one, I'm going to do 6 divided by 4. That's the same as 6 times a fourth. That's 3/2. And if you really like decimals, you can say 1.5. Okay, so they're telling us to go from N to M. They might flip that around. I keep saying that. They might say go from M to N. In that case, we would go in the reverse direction. Here we're going to start over here, and what we're going to do is add this amount to the X's and this amount to the Y values. So from minus 3, we're going to add 1.25. So minus 3 plus that is going to be negative 1.75. Make sure it's negative. And then from the Y, negative 3, we're going to add 1.5. So negative 3 plus 1.5. That'll take us to minus 1.5. So these are our new coordinates for the X and the Y. So let's go back 1.75, so that's back 1. And okay, so 1.75, probably around there on my x-axis. A little mark there. And then in the y direction, we're going to go down 1.5. So down 1 and about a half. Okay, so about right here. That point is going to be 1/4 of the distance from N to M. So those coordinates as decimals are going to be 1.25. Sorry, getting my numbers mixed up here. Keep in mind, these are my final coordinates. So give that point a name. How about T? So T is at the point minus 1.75, comma, minus 1.5. Now if you wanted to use improper fractions, which we are going to use quite a bit, you can convert those to improper fractions, and that would be the fractional version of those things. What I want you all to get from this is this overall process where we find the changes in the x's, find the changes in the y's, and then we have to take the correct fractional distance of those changes, and then we'll either move forward if we're starting from N and going towards M, or if they wanted us to go from M to N, we would have moved backwards. So how that would work out is on each of these, instead of adding, I would have subtracted. That's all you guys need for today.